In the last section there, we talked about fractions and reducing fractions and equivalent fractions using factors. We're going to kind of carry on with that into something similar, which is equivalent ratios. And so ratios are just ways of comparing quantities with the same units. We often write them as a number colon another number. So it could be like 4 to 6, something like that. They can be also written as fractions as well. It just depends on the situation. You might see something like this in terms of mixing. A bag of rice might have a ratio of 2 to 1, meaning 2 parts water to 1 part rice. And so we use the ratios because they allow us to use whichever units we want to for that. So 2 parts water to 1 part rice could be 2 cups of water to 1 cup of rice. Could be 2 gallons of water to 1 gallon of rice, depending on how much you're making. And so that allows you to play around with the proportions that you're making. Commonly used in baking, commonly used in when you're doing betting. It's a common way of giving odds. If you go to a casino and look at a lot of the table games, they'll actually have these numbers like this written on the table. You know, you play roulette. You're going to see a 2 to 1 if you bet on red. If you bet red, they'll pay you $2 for every $1 that you bet, kind of thing. So there's 2 types of ratios that we work with. There's the part-to-part ratio that compares a part of a group to another part. So in terms of our rice mixture, we could have 2 water to 1 rice. That would be a part-to-part. In terms of the other type of ratio is a part-to-whole, and that compares part of the group to the total. So the rice, we have 1 rice to 3 parts total in terms of our rice mixture. Or we have 2 water to 1 total. Or 3 total parts. And we would just write, and we wouldn't put the rice and water, we just are writing those there just to illustrate the principle. So we can compare parts to other parts, or we can compare a part to the whole group. So an example, we have 10 cats and 8 dogs at a pet store. What is the ratio of cats to dogs? Well, we have the word 2, and the 2 part is going to be our colon. So cats to dogs, we're going to have 10 to 8. And now, if we ask for the ratio of dogs to cats, that flips everything, because now dogs go first. So we're comparing dogs to cats. So the order of what we state here matters in how we write it here. Just like our rice, if we were to take our rice mixture and say, well, it's what's the mixture of water to rice, and say, well, it's 1 to 2 because there's 1 part rice and 2 parts water. 1 to 2 water to rice would put too much rice and too little water in. So you have to be careful in the order that things are stated. If we want to compare the number of dogs to the total number of pets in the store, then we can write it in terms of a part to whole. And so there are 8 dogs to 18 pets. Now I said write your answer 2 ways. So another way that you can write a ratio is you can write it as a fraction. And the part to whole ratio is the one that we would write as a fraction because there's 8 out of the total of 18. 8 over 10 doesn't make a proper ratio because we're not comparing it to the whole group. So only when we're comparing it to the whole group can we write it as a fraction. So part to whole is how we write. We can write it either way. Now, another definition. We talked about equivalent fractions. Well, now equivalent ratios are ratios that are the same when written in lowest terms or when is the clean definition of it. But let's look at some examples. They work just like fractions. Ratios can be reduced by dividing out a greatest common factor. They can also be, you can also multiply to find equivalent ratios, but in this case we're getting the lowest terms. So the lowest terms we want to divide out the common factor. So these are 3 types of ratios. 6 and 18, what's the common factor there? Well, it is 6. So they both have a common factor of 6, and when we divide both by 6, we get 1 to 3. So that's the ratio in lowest terms. And in the next case, we have 14 to 35. Common factor is 7. We divide both of those by 7. We get 2 to 5. If it's in fraction form, same idea. Divide by the common factor. In this case, it's 3. We get 4/5. Even if there's multiple terms, or more than 2, 8, 12, and 20, we have to find the greatest common factor in all 3. So 8 and 12 and 20 have a common factor of 4. And so we divide everything. It's not percent, divide. Divide by 4, divide by 4, and divide by 4. So we're going to divide everything by 4. We're left with 2 to 6. Or sorry, 2 to 3 to 5. In the next one, 7, 8, and 10. 8 and 10 have a common factor of 2, but 7 doesn't. 7, 8 don't have any common factors other than 1. 7 and 10 don't have any common factors other than 1. So the greatest common factor is 1, which means this reduced is just how it is. 7, 8, and 10. Dividing everything by 1 doesn't change any of the numbers. And so in the next part here, we want to show that these ratios are equivalent, and we want to show it 2 ways. So to show these equivalent ratios, what we can do is show that 3 to 7 equals 6 to 14 because it can be multiplied by 2, and that can be multiplied by 2. Or we could show that 6 to 14 equals 3 to 7 because 6 divided by 2 and 14 divided by 2 will give us our 3 and 7. So you can either multiply this one up or we could divide this one down. And as long as we're multiplying and dividing by the same number, that shows that they're equivalent. In the next one here, we can use the same idea. 4 over 5 equals 48 over 60 because we can do 4 times, what do we got here? 12 and 5 times 12. So that's the same number in both cases. And then again, 48 over 60 equals 4 over 5, because 48 divided by 12 and 60 divided by 12 are 4 and 5 respectively. And then the last bit here, we can use this concept of equivalent ratios to find a relationship between a missing value between them and find the relationship. So here, if we look at the 1 and the A matchup, the 2 and the 10 matchup, and the 3 and the C matchup, 2 to 10 requires us to multiply by 5. So we're going to multiply 1 by 5. A is 1 by 5, which is equal to 5. C is equal to 3 times 5, which is equal to 15. So there's our A and C. So 1 to 2 to 3 equals 5 to 10 to 15. So long as we multiply both of these numbers by the same thing that 2 is multiplied by to get 10, we have an equivalent ratio. And that is it for equivalent ratios.